Welcome viewers, in this video we will see the details about tie set schedule available in the network topology. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In network topology, the tie set schedule. We know that the network is nothing but the combination of elements: resistor, inductor, capacitor, voltage and current source. If you represent the network by the line, is called a graph. The directions also given in the graph mean oriented graph. Then we have the incident matrix. That matrix will give the details about how many nodes, how many branches, whether the current is going towards the node or away from the node or not connected. That details is available in the incident matrix. So we have network, graph, oriented graph, incident matrix. And also we have the tree. From the graph we can draw the n number of trees. Tree is the subset of the graph, contain 2 or 3 branches but not a closed loop. So from this tie set schedule is based on the tree. Now we'll see the details. Imagine a tree of a given graph. From the graph we can form the several trees. Addition of a link to the tree result in closed path or loop and link currents. So tree is the subset of the graph. So graph contain 4 or 5 networks. The tree can be contain 2 or 3 nodes with the few branches but not a closed loop. Suppose the tree is closed with the loop and link current, then it is called a tie set schedule. So tree with the closed loop or loop and link current is the tie set schedule. Now we'll see the further detail. The current in any branch of the network may be obtained by noting the link current flowing through the concerned branch by taking into account of both magnitude and direction. So current in any branch of a network can be calculated from link current flowing through the branch. So from the link current we can able to find the branch current. So as an example, consider the following graph. How we are finding the branch current from the link current. So this is the graph called a oriented graph. This is a network. Network is replaced by the line and directions also given. So it's a oriented graph. So 4 nodes are available. 1, 2, 3, 4 and this one. 5 nodes are available. There are 8 branches available. 1, 2, 3, 4, 5, 6, 7, 8. So these are all called the branches. 5 nodes with 8 branches are available. So from that we can draw the tree. I already told tree is the subset of the graph, not a closed loop. This is the one type of one tree. Like that we can have n number of trees. So the maximum possible tree formula is available. Determinant of A multiplied by transpose of A will give the maximum number of trees. That is different. Here we consider one tree. If the tree is closed with the link, then it is called a tie set schedule. Now consider this tree. We are going to draw the tie set based on this tree, right? Here the branches 5, 6, 7, 8 are available. 1, 2, 3, 4 is not available here. Now we'll see how to convert this tree into tie set, right? So from graph we drawn one tree. Like that the n number of trees are there. But here we consider this tree. We'll see how to convert this tree into tie set. So the branches are numbered as 1, 2, 3 up to 8 and the directions are given for branches by random. Directions are given by our own, randomly given. So that let I1, I2, I3 up to I8 be the branch currents. Based on the previous diagram, 8 branches are there. That is marked as I1 to I8. Now consider this diagram. This is the tie set. So this is the tie set. We will see how it is drawn. This is the tree what we already decided. 5, 6, 7, 8. Branch current 5, 6, 7, 8 are available in the tree. Now these lines are drawn. That is a link. 1, 2, 3, 4 is the link. Branch 1, 2, 4 form the link. 5, 6, 7 already available in the tree. Now we are making the tree into tie set. So that we are considering the branch 1, 2, 3, 4. Branches 5, 6, 7, 8 constitute branch voltage. Link current in the tree are shown as given or given by. Right. So I5, I6, I7, I8 already available in the tree. I1, I2, I3, I4 we connected in order to make it into tie set. The link currents are denoted by small letter I. So apart from I1, I2, another 4 currents are there. Small I1, I2, I3, I4. That is the link current. These I1 to I8 branch current. Right? The link current is denoted by the red color, small letter. Branch currents are denoted by capital letter I. So small letter I, link current, capital letter I, the branch current. Now we'll see how we can find the branch current from the link current. See this I1. I1 is nothing but this branch current I1 is nothing but link current I1. So same current is flowing through the branch I1. So I1 equal to I1. Branch current I1 equal to link current I1, small I1. Similarly I2. This I2, small I2 is equal to capital I2. Both are equal. Branch current I2 equal to link current I2. Similarly I3. Branch current I3 equal to link current I3. I4. Branch current I4 equal to link current I4. So I1, I2, I3 branch current is equal to the link current. But I5, this I1 also flowing and I2 also flowing. I1 is flowing downwards, I1 is flowing upwards. So the difference between these two current is the I5, I2 minus I1. First 4 same, branch current and link current. For I5, I6, I7 is the difference because two currents are flowing. Then I6, here I3 is flowing as well as I2 also flowing. So I3 minus I2. In I7, I3 is flowing and I4 is flowing. So I4 minus I3. I8, I1 and I4 is flowing. So I1 minus I4. So from the link current, we can easily identify the branch currents from I1 to I8. So these 4 links are available. I1, I2, I3, I4, the branch current can be computed. From the link current, we can compute the branch currents. So now see what is the tie set. The link current I1 is flowing through I1, I5 and I8. 1, 5, 8 branches. So the link current I1 flow through the branches I1, I5, I8. That I1 is not flowing through I6 and I7. Not flowing through the remaining branches. Only it is flowing through I1, I5, I8. Not flowing through I2, I6, I3, I7 and I4. So this link current I1 with branch current I1, I5, I8, this is the tie set. This is one tie set. Similarly I2, link current I2, branch current I5, I2, I4, another tie set. Link current I3 with branch current I6, I3, I7, so another tie set. Link current I4, branch current I8, I7, I4 is another tie set. So this is 4 tie sets are available. So the details are given. So what we discussed, the details available. The link current I1 traverse the branches 1, 5, 8. These set of branches form the closed loop. The link current I1 flowing through this loop. So this set of branch is called a tie set. So what we discussed, same thing. Similarly, we can go for a link 2, 3, 4. In that current I2, I3, I4 are flowing. That is also a tie set. If the network geometry is complex, the above method of writing tree branch currents may be tedious and confusing. For a complex problem, we cannot apply this method. So a symmetric way of indicating the link is given by using a schedule. So this is the tie set. Now we see tie set schedule. By making tie set schedule, it becomes easier. Table gives a schedule for the graph and the tree as discussed above. Now we'll see the tie set schedule. This is the tie set. What is tie set? Link current with the branch current form the closed loop, that is a tie set. Like that we have 4 tie sets are available. But only this tie set, if the network is complex, it is very difficult. So that we can go for a tie set schedule. Now we'll see how to form the tie set schedule. So before going to the tie set, some important points we'll see that. Note is there. We can choose any other tree. We chosen one tree, but we can use any other tree also we can choose. The direction of link current is so chosen that I1 flows in the direction of I1. Link current I1 flows in the direction of branch current I1. Similarly, I2, link current I2 flows in the direction of branch current I2 and so on. So, link current and branch current we are make it as same direction. I1 with I1, I2 with I2, similarly I3, I4. These are all the important things. Now we'll go to the tie set schedule. What is the tie set schedule? So this tabular column will give link number. This is a node 1, 2, 3, 4. There are 4 links are available. And 8 branches are available already we discussed. 1, 2, 3, 4, 5, 6, 7, 8. Now this plus 1, minus 1, 0 indicates 0 means the link 1 is not connected with branch 2, 3, 4, 6, 7. Only it is connected between 1, 5 and 8. We'll see the diagram. Plus 1 means it is going away. Minus 1 means going towards. 0 means not connected. Now we'll see the diagram. Link 1 connected with 1, 5, 8. We'll see the diagram now. See this. This is the link 1 connected with 1, 5, 8. Right? The 1 is going towards. We'll take this is the link. This is towards so minus 1. This is also towards minus 1. This is away. So plus 1. So that is the thing available in the tab. Like that we can go for other thing also. So 1 and 8 plus 1, 5 minus 1. Here the plus 1 and minus 1 we can take this the current, link current and branch current same direction. So plus 1. I8 also same direction, plus 1. But I5 and I1 opposite direction. It is going down. I1 going up. So minus 1. Accordingly it is written. Both the currents are same direction plus 1. Opposite direction minus 1. Accordingly we can write remaining also. So this is based on that. This tabular column is done. This is called a tie set. So from this tabular column we can easily identify in link 1 the branch current 1, 5, 8 is connected. Plus 1 indicates link current and branch currents are same direction. Minus 1 indicates opposite direction. Similarly link 2, 3, 4. So from this how to find the branch current? I1 equal to I1. See this, in this branch current only I1 is there, remainings are 0. In branch current 2 only link 2 is connected. In branch current 3 only link 3 is connected. In branch 4 only link 4 is connected. So capital I1 equal to small I1, I2 equal to I2, I3, I4. So what we discussed in the diagram, the same thing reflected in the tabular also. In branch 5 I1 and I2 is there. So it is I2 minus I1. In I6, I2 and I3 is there. So I3 minus I2 plus First we'll take the plus, then minus. I7, I4 minus I3, I8, I1 minus I4. The same thing only we discussed in the tie set diagram. The same thing here reflected in the tie set schedule also. So in this, the first column consists of link numbers 1, 2, 3, 4. These pertain to the 4 loops causing 4 loop current I1, I2, I3 and I4. So the first column is the link current, that is due to the link number, that is due to the link current. Now we'll analyze this tabular column. First we'll go to the first row. We are going to analyze the first row. Some analysis what we discussed is available in the Waddings. Description is available. If branch current and link currents are in same direction, insert +1, opposite direction -1, that we discussed. No, not flowing means 0. First we'll analyze I1. I1 is flowing through branch 158, forming the tie set. So I1 flowing in branch 158 is the one tie set. In first row under the branch 158, we entered 1, -1 and 1 respectively. That means this 1 refers the branch current 1 and link current are same. Similarly 8. Only in 5 both are opposite, so -1. So I1 is not flowing through the branch 2, 3, 4, 6 and 7. So in the first row we wrote the zeros below the branch 2, 3, 4, 6 and 7. So what we discussed, the same thing is given here. Only 158 link current is flowing. In that 1 and 5, 1 and 8 same direction, so placed 1. In branch 5 opposite direction -1. 2, 3, 4, 6, 7 the current I1 is not flowing, so placed as 0. Similarly we go for the second column, second row. So in the second row I2 is flowing through the branch 2, 5 and 6. 2 and 5 same direction, so +1. 6 opposite direction -1. So that is given. That I2 not flowing in 1, 3, 4, 7 and 8. For that we placed 0. Similarly we can go for a third and fourth row. We can fill up the elements. Each row of the schedule indicates the element of one tie set. So the every row indicates indicate the one tie set. The entire schedule consists of 4 rows corresponding to tie set is called a tie set schedule. Every row is the tie set. Entire thing is the tie set schedule. So with the help of this, with the help of the tie set schedule, branch current can be written in terms of link current as we discussed earlier. That is branch current I1 equal to link current I1. Branch current I2 equal to link current I2. So from the tie set schedule, we computed the branch current in terms of link current. So that is given here. So in this video we discussed the tie set schedule. What is the tie set schedule? How to frame the tie set schedule from the oriented graph. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the tie set schedule. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Tie set schedule, solved problem 1, coming under the network topology. The problem statement is, for the network given, draw the graph and a tree. Show the link currents. Write the tie set schedule for the tree. The equation for branch current in terms of link current. Also write the independent equations. So these are all the parameters we need to identify. Now we'll refer the given network. So this is the given network. Network is nothing but a interconnection of elements. Here the resistors are available. 6 resistors are interconnected, called a network. having the 4 nodes are available, A, B, C, D. Node is nothing but connection of elements. So at node A, 3 resistors are connected and 6 branches are available. Branch is nothing but element connected between the node is called a branch. 1, 2, 3, 4, 5, 6. 6 branches are available. 4 node and 6 branches are available. The network can be represented by the graph. Graph is nothing but network elements are replaced by the straight line. It's called a graph, so that we can easily understand. If the direction is also given, that is called a oriented graph. So this network is drawn like a graph with directions are given. So this is a oriented graph. B, C, D and A. So here also B, C, D, A. 4 nodes are available. These branches also represented 3, 4, 2, here 5, 6 and 1. The resistors are replaced, only straight lines are written. This is called a oriented graph. The direction of branches are given by our own choice. The direction is given by our own choice. Direction is not given in the diagram, but by our own the directions are given. So first one we identify the graph. This is the oriented graph. Now we'll go to the next one, tree. We need to identify the tree for the given graph. So what are the terms available here? The total number of node is 4. A, B, C, D. Total number of branches 6. From that we can find the number of tree branches. If you draw the tree, how many branches are there? N equal to nt minus 1. Number of node minus 1. Number of node is 4. 4 minus 1, 3. So in a tree, the number of branches will be 3. The number of link, L equal to B minus N. B is branch, 6 branches. N is number of branches in the tree, 3. So 6 minus 3, 3. So the number of links are 3. The number of independent loop current is 3. Here the 3 loops we can form by seeing the network itself. We can say 3 loops. So it is given by 3. Now we'll go to draw the tree for the given network. So the tree is nothing but a subset of the graph, not a closed loop. We already identified there are 3 branches are available in a tree from the formula, right? So this is one of the tree. Like that we can draw a number of trees. Maximum possible trees, the formula is available. Here we consider this tree. Node A, B, C, D. We consider the branches 3, 5 and 6. So in this tree, the 3 branches 3, 5, 6 is available. For this branch, we need to go with the link current. So the branches not available here is 1, 2 and 4. So this 1, 2, 4 will form the link. So that is given. The tree consists of 3 branches. One of them is chosen. It consists of the branch 3, 5, 6. The other branch will form the link. 1, 2, 4 will form the link. So in the tree, by connecting the link is called a tie set. Right, now we consider this tree. Now we'll draw the link by using the branches 1, 2 and 4. So that diagram is given here. So this is the graph with the link current. So this is the tree. 3, 5, 6 is the tree. Now we drawn 1, 2, 4. That will form the link. Tree with the link is called a graph with link current, a tie set. So the node A, B, C, D, 6 branches, 1, 2, 3, 4, 5, 6. This branch current. Now we'll see the loop current. A small I1, I2, I3. This is loop 1. We know that loop is nothing but closed circuit. This is second loop. This is third loop. Loop 1 having branch 1, 5 and 6. Loop 2 having 2, 4 and 6. Loop 3 having 3, 4 and 5. So this is the tie set tree with the link current. Now we'll see the branch currents here. The loop 1, 2, 3. 3 loops are there. And what is the branch current? So this is the branch current. This is the loop current. Both the directions are same, +1. Both the directions are opposite, -1. Not available means 0. So first we will consider the loop 1. See this loop 1 current I1, both are same direction. So branch 1 is plus 1. While coming to this branch 6, that is also same. The same. Branch 6 is going with the opposite direction. Branch 5 same direction. Right, so it is the branch 5 is plus 1 and branch 6 is minus 1. Right, so I1 is the loop current, 1, 5, 6 is the branch current, both are equal, both are same direction, plus 1, opposite direction minus 1, not there means 0. So branch 1 and loop 1 are both are same direction, plus 1. 6 is opposite direction, loop current is flowing this direction and branch current is flowing that direction, so minus 1. Then current is flowing like this, so both are same direction, plus 5 is plus 1. Then we'll go to the second loop. Second loop having 2, 4 and 6. 2, 4, 6. What about this 1, 5, 6 mean? What about the 2, 2, 3, 4 is 0. 2, 3, 4 not covered with the loop 1, so it is 0. Now we'll go to the loop 2. See the current direction. 6 same direction. 2 also same direction. Only 4 is opposite direction. The current is flowing like this clockwise. So 2 and 6 same direction, only 4 is opposite direction. 4 is coming down, loop current is going away, going up, 4 is coming down. So 4 is minus 1, 2 and 6 is plus 1. What about the remaining 3, 5 and 1? That are all 0. Then loop 3. Loop 3 also flowing in the clockwise direction. So it is flowing like this. So I4 is same direction, I3 also same direction. I5 is flowing this side, but I3 flowing that side. So only I3 opposite side. I3 and I4 same side. I3 and I4 same, only I5 minus 1. So by using that we can go for the tie set schedule. This is the tie set diagram. We'll go to the tie set schedule by using this tabular column. Here only the branches covered in the loop 1 is given, 1, 5, 6. 2, 3, 4 is not given. We need to write all the branches, then it is called a tie set schedule. Now we'll go to the tie set schedule. So here the link currents are marked as a small letter, I1, I2, I3. The branch current is written as capital letter, I1, I2, I3, I4, I5 and I6. 6 branches are available. Link current means 3 loops are available, I1, I2, I3. So this is the tie set schedule, what we discussed earlier. Here all the branches available. Earlier only the covered branches are available. So loop 1, 2, 3 having branch 1, 5, 6 that we already discussed, plus 1, minus 1. 2, 3, 4 not connected, so it is 0. Similarly branch 2, loop 2 connected with branch 2, 4, 6, that values are already we discussed, remainings are 0. Loop 3 connected with 3, 4 and 6, branch 3, 4, 5, the values are available. These two are plus 1, these are minus 1, remainings are 0. So this is the tie set schedule. From this tie set schedule we can write the relation between link current and branch current. The branch current in terms of link current. First consider this branch 1. Only here plus 1 is there. That is I1. This is a loop 1. So this is branch current, capital letter. This is loop current, small letter. See this, only this is plus 1. Remaining 2 are 0. Let us consider this maybe I1, I2, I3. Only I1. So capital I1 equal to small I1. Then branch 2. Branch 2 here only 1 is there. That is I2. So capital I2 equal to small I2. Then branch 3. At loop 3 here plus 1 is there. So capital I3 equal to small I3. Then capital I4. There 2 values are available. Minus 1 and plus 1. Loop 2 minus loop 3 plus. So I3 minus I2. The first positive minus negative. In branch 5 here plus 1. Loop 1 plus 1. Loop 3 minus 1. So I1 minus I3. I1 minus I3. First 3 branch only 1 values are available. So easily we wrote. Here 2 values are written. So we need to write the difference between these two. For branch current 6, loop 1 is minus 1, loop 2 is plus 1. So I2 minus I1, I2 minus I1. So this is the relation between the branch currents are given in terms of the link current or loop current, right? So from the tabular column easily we can write branch current means I1, I2, I3. Loop current means small I1, I2, I3. Where the values are available, that alone written. Capital I1 equal to small I1. Capital I2 equal to small I2. Capital I3 equal to small I3. Capital I4 equal to two values are there. So I3 minus I2. Like that we can write. So the equation are numbered as from 1, 2, 3, 4, 5, 6. Numbered as 1 to 6. So equation 1, 2, 3 form the identities. Hence branch current is equal to the concerned loop link current. Both are same. Branch current and loop are same for the first three equations. Equation 4, 5, 6 are called the independent equation. That is also question is there. Find the independent equation. So 4, 5, 6 are the independent equation. So in this video we discuss the network topology tie set schedule. For the given network, first we draw the oriented graph, then tree with the link current, then we calculated the tie set schedule, then the relation between link current and branch current. First three equation identities, remaining three equations called a independent equation. So we calculated all the parameters what is asked in the question. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the tie set schedule. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Tie set schedule solved problem 2 coming under the network topology. First we will see the statement of the problem. For the network, draw the graph, tree, tie set schedule and find the loop current and branch voltages. So for the given network we need to draw the graph, tree, tie set schedule, loop current and branch current. We need to find the loop current and branch current. So this is the given network. Network is nothing but the combination of elements. Here we have voltage source and resistors. They are connected. That is called a network. Having the three nodes are available, A, B and C. Node is a junction where the elements are connected together. So A, B, C, three nodes are available. And there is a two closed loop is available. Closed loop means is a closed path. This is a closed loop. The current I1 is flowing through the closed loop. The second closed loop, current I2 is flowing. So three nodes available, two loops available. Loop current is I1, I2. So one of the question is we need to find the loop current I1 and I2 and branch voltage across each and every element. This 10 ohm, we have to find the voltage across each and every branch. Branch is nothing but the element connected between the node. For example, between A and C, 50 voltage is connected. A and B, this 10 ohm is connected. B and C, 10 ohm connected. B and A, one more 10 ohm connected. So this is the branch voltage. The first one we need to draw the graph for this given network. What is the graph? The network elements are replaced by the straight line. Only by represented by the straight line is called a graph. If the direction is also given means oriented graph. So this 50 voltage, these resistors are simply represented by the straight lines. Same, the three nodes A, B, C. Between A and C, node 1. This is called branch 1. That is nothing but this voltage source. And A and B, between A and B, two resistors are connected. One is 3, another one 4. Branch 3, branch 4. Between A, B and C, one more resistor, branch 2. So three nodes A, C, B and 4 branches. 1, 2, 3, 4. The directions are our own directions, not given in the problem, the directions are made as per our own term. So this is called a oriented graph. Now we'll see the further detail. So the number of node is nt, n suffix t is 3, that is ABC. Number of branches are 4, these 4 branches. From that we can find number of branch tree. What is mean by tree? The tree is the subset of the graph, part of the graph. Here 3 nodes are available. Part of the graph is called a oriented graph, from the oriented graph called a tree. Less number of branches will be there. And also it should not be closed loop. So this is one of the tree. Now we'll see the detail. Number of branch tree, the branches in the, how many branches available in the tree is n equal to nt minus 1. So nt is available 3 minus 1, 2. So there should be 2 branches in a tree. Number of link L equal to b minus n. B is branch is 4, n is number of branch tree is 2. So 4 minus 2, 2. So 2 trees in a 2 branches in a tree, 2 links in the same tree. And independent loop is 2. Already we have 2 loop, L I1 and I2. So this is one of the tree having 2 branch, 1 and 4. Similarly we can have 1 and 2, 1 and 3, 2 and 3, 3 and 4, like that. So we consider only this tree having 1 and 4. So the remaining 2 and 3 will form the link. Let branches 2 and 3 be the link. So the link with tree is the tie set. We will see the next diagram. At that time we were able to understand. So that this is the tree. In that we are going to draw the link 2 and 3. So 1 and 4, 3, 2 and 3 link. So the network oriented graph completed, then tree completed. Now we'll go to the tie set schedule. So the oriented graph with the link currents are shown below. So 1 and 4 is the tree. In that we have 3 and 2, 2 and 3 that form the link. So completely this is nothing but a oriented graph with the tree. 3 node A, B, C, branches 1, 2, 3, 4. 1 and 4 we consider tree, 2 and 3 we consider link. Now here the 2 loops available, I1 and I2. Loop 1 with the current I1, loop 2 with the current I2. Now we can go the tie set schedule. Tie set schedule means here in the vertically we have loop is available, loop 1 and 2. Here branches are available, 1, 2, 3, 4, 4 branches. So we are going to relate the loop with the branches. If the direction of the branch as well as direction of the loop both are equal means plus 1. Both are opposite means minus 1. No link means 0. So first we will consider the loop 1. Loop 1 what we have, 1, 2, 4 available. 3 is not available in the loop 1. So 3 is 0. Loop 1, the branch 1, branch 2 and loop current both are same. So it is flowing in a clockwise direction. So the direction of branch 2 as well as loop 1 is same, so that plus 1. So here also same, going down. Here also, but the loop 4 going up. So the loop 4 is, branch 4 is minus 1. Here the loop current is flowing like this. The branch 1 also going upwards and loop 1 also going same direction, plus 1. So loop 1 direction, branch 2 direction both are same, plus 1. Loop 1 and branch 4 directions are opposite. This is going down, branch 4 going up. Both are opposite. So minus 1. And branch 1 going the same direction. Current is flowing in clockwise direction. So loop 1 also clockwise direction. So plus 1. 3 is not connected, 0. I will consider loop 2. So only 3 and 4 available. So 1 and 2 is 0. 1 and 2 not covered in the loop 2. Only 3 and 4. See that 3 direction is going down. This is also going down. Same direction, clockwise. So plus 1. So this is also same, going in the upward direction. So going like this. So branch 4 also and loop 2 current also same direction. So plus 1. So this is called a tie-set schedule. So the branch currents are represented by capital I1, I2, I3, I4. Loop or link currents are marked as small I1 and I2. Branch voltages are V1, V2, V3 and V4. Right. So from this we can form the voltage equation as well as current equation. By applying KVL we can write the voltage equation. What is the voltage equation? We already represented V1, V2, V3, V4. So here 1 into V1, 1 into plus 1 into V2 plus 0 into V3 plus minus 1 into V4. Like that we can write the equation. Similarly here 0 into V1 plus 0 into V2 plus 1 into V3 plus 1 into V4. Like that we can write. Then how will you write the current? See, this is here, this is I1, I2. This is capital I1. Right? We can write like this. This is small I1, I2. This will be capital I1, I2, I3, I4. So see, this I1 is available in the only loop 1. So I1, capital I1 equal to small I1. This I2 is 0. Similarly, I2 also available only in loop 1. So I2 equal to small I1. Similarly, I3 available only in I2. So I3 equal to I2. I1 is 0. I4, both I1 and I2 is available. I1 is negative, I2 is positive. So I2 minus I1. So from this tabular column, we can write the voltage equation as well as the current equation. I1 is, capital I1 is small I1. Capital I2 is small I1. Capital I3 is I2, small I2. I4 is I2 minus I1. Now we'll see this equation one by one. So we already discussed the tabular column. Directly we can see the equation. For each row, KVL is applied to get the equation in terms of branch voltage. So applying KVL to the row 1, we already discussed 1 into V1 plus 1 into V2 plus 0 into V3 plus minus 1 into V4. So this is the values available in the tabular column. So this V3 is 0. We have V1 plus V2. This is minus V4 equal to 0. We'll take this equation number 1. Similarly, applying KVL to row 2, 0 into V1 plus 0 into V2, these two values available in the tabular column, plus 1 into V3 plus 1 into V4. So first two values are 0, only we have V3 plus V4 equal to 0. Equation number 2. So we got the two voltage equations. Similarly, we can go for the current. How will you find the current equation? The relation between branch current and link current is obtained by considering the column separately. We already discussed capital I1 equal to small I1, capital I2 equal to small I1, I3, capital I3 equal to I2, I4 equal to I2 minus I1. Right? So these three, equation number 3, 4, 5, 6. This number as 3, 4, 5, 6. So this is also obtained from the tabular column. They already discussed. So from the circuit, the branch voltages we can write. V1 equal to minus 50. V2 equal to 10 ohm into I2. This I2 is nothing but small I1. So 10 I1. V3 is another resistor, or in that current flowing is I3. This I3 is nothing but I2. So 10 I2. V4 equal to 10 I4. That is V equal to I into R. R value is 10. I value is either I4, I3 or I2. I4 is nothing but I2 minus I1. So 10 I2 minus I1. Now voltages are written in terms of loop current, link currents. Right? Branch current means I1, I2. This is written in the loop current. This is numbered as equation 7, 8, 9, 10. I think we are able to understand this. We will see the circuit diagram so that we are able to understand. So this is the circuit diagram available. So V1, 50 minus 50 voltage. This is V2. V equal to I into R. I1 into 10. This is V3. 10 into I2. This is V4. 10 into 2 currents are there. One current is going down, another current is going up. So I2 minus I1. So based on that, we wrote that equation. This equation is written from the circuit diagram. So numbered as equation 7, 8, 9, 10. From that we can find the values. Our aim is next we need to find the loop current and node voltages. These two we need to find, loop current and node voltages. So from equation 1, that is the voltage equation, V1 plus V2 minus V4 equal to 0. Now we have V values are available, voltage values are available. So we can substitute this value. V1 is minus 50, V2 is 10 I1, V2 is V2 equal to 10 I2, it is 10 I1. So this is I1, 10 I1. V4 is 10 I2 minus I1. Right, now this is minus is there. Now we'll multiply minus 10 plus 10 I1 minus 10 I2 minus plus 10 I1. So I1 available plus 10 I1 here plus 10. So 20 I1 minus 10 I2 minus 50 is brought that side. So plus 50. So 20 I1 minus 10 I2 equal to 50. We'll make this equation number 11. Similarly, equation 2, V3 plus V4 equal to 0. V3 is 10 I2. V4 is 10 I2 minus I1. So multiply inside, 10 I2 minus 10 I1 equal to 0. So here 10 I2 plus 10 I2 become 20 I2. Divided by 2, divided by 10, it become 2 I2 minus I1 equal to 0. So 2 I2 equal to, brought that I1 that side. So it become plus I1. So I1 equal to 2 I2. I1 equal to 2 I2. We got one relation. Equation number 12. Now we'll substitute this I1 equal to 2 I2 in the equation number 11. Right. So 20 I1. I1 is nothing but 2 I2. So I1 is replaced by 2 I2 minus 10 I2 equal to 50. You multiply 20 into 2, 40. 40 I2 minus 10 I2 equal to 50. 40 I2 minus 10 I2 is 30 I2 equal to 50. So I2 equal to 50 by 30, that is 5 by 3. So that I2 equal to 5 by 3. So we got the loop current 2 I2 equal to 5 by 3. So I1 can be calculated from this equation. So I1 equal to 2 into I3. We can substitute this. Now we'll find the I1 value. So substitute I2 equal to 5 3 in equation 12. Equation 12 is I1 equal to 2 into I2. This I2 is replaced by 5 by 3. So 2 into 5, 10, 10 by 3. So I1 equal to 10 by 3. So now we calculated the loop current. I1 is 10 by 3. I2 is 5 by 3. So by using this value, we can easily calculate the branch voltages. Branch voltages can be calculated. V1 is already minus 50 voltage. From the diagram itself it is given. V2 equal to 10 I1. So 10 into I1 is nothing but 10 by 3. So 100 by 3, that is equal to 33.33 voltage. V2. V3 also 10 I2. V3 is 10 into I2. So 10 into I2 is 5 by 3. 10 into 5, 50. 50 by 3. 50 by 3 is 16.67 voltage. V3. Then V4. V4 equal to 10 I2 minus I3. So 10 into I2 is 5 by 3 minus I1 is 10 by 3. So 10 into, we take these 3 commonly. So 5 minus 10. 5 minus 10 is minus 5. So 10 into minus 5 by 3. So minus 50 by 3. That is minus 16.67 voltage. So now we calculated V1. V1 is already given minus 50 voltage. V2, V3 as well as V4. So node voltage as well as loop currents are calculated. So in this problem we discussed the tie set schedule from the network. First we drawn the oriented graph. Then we draw the tree. Then the tree is converted into converted with link current. Then we design the tie-set schedule. From the tie-set schedule, voltage equation and current equation is framed. By solving this equation, we are able to identify the value of loop current and node voltage. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the solved problem based on the tie-set schedule. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Tie-set schedule, solved problem 3, coming under network topology. For the network shown, draw the graph, tree, tie-set schedule and current through 20 ohm resistor. Also find the voltage across the elements. Voltage across all the elements. So this is the given network. So the network is nothing but combination of interconnection of the elements. Here 2 voltage source available, 3 resistors are available. It's interconnected. It's called a network. So this A, B, C is nothing but a node. Node is the junction point where the elements are connected. Node A, B, C and D. So from this network we can draw the oriented graph. That is nothing but the elements are replaced by the straight line. Only simply the line will be drawn. That is called a graph. If the directions also available means it is called a oriented graph. Elements replaced by line is a graph. Directions are available mean oriented graph. So here we have, there are 4 nodes A, B, C and D. The branches 1, 2, 3, 4, 5. Branch is nothing but a element connected between the node. This one is nothing but a 20 voltage source. 2 is nothing but 10 ohm. 3 is another 10 ohm. 5 is 20 ohm. 4 is 40 ohm, 40 voltage source. So these directions are given according to our own directions are given. Directions are not specified in the problem. So the first question is we need to draw the graph. So this is the graph of the given network. Now we'll see the further detail. So the number of nodes available in this problem n suffix t is 4 nodes A, B, C, D. Total number of branches B equal to 5. There are 5 branches are available. Then total number of tree branches. Tree means subset of the graph. Part of the graph is called a tree. That is not a closed loop. We can draw the n number of trees from the oriented graph. So how many branches are available in the tree is the number of tree branches. That can be calculated n equal to n suffix t minus 1. Number of nodes minus 1. 4 minus 1, 3. So there will be 3 branches in the tree. Total number of link L equal to B minus n. 5 branch minus 3 branches. So 5 minus 3, 2. 2 links will be there. The number of independent link equal to 2. Already we have 2 loops are available. This is the loop. Loop 1, loop 2. Loop means closed circuit. Current in the loop 1 is I1. Current in the loop 2 is I2. Now we'll see the tree. This is one of the tree available for the given network. 1, 4, 5. 3 branches are available. Node A, B, C and D. So it is not a closed loop. Part of the graph is the tree. All nodes are available. Branches are 1, 4, 5 available. So the remaining 2 and 3 is form the link. Let branches 2 and 3 form the link. Link is nothing but closed circuit. So by using 2 and 3, by connecting 2 and 3, we can go for the link. So the tree with the link is called a tie set. Tie set means link with the tree. So here the tree is contain the branch 1, 4, 5. Link is 2 and 3. Now we'll see the tree with the link, that is called a tie set. The diagram for tie set. So this is the tie set. 1, 4, 5 tree. Then 2 and 3 is connected. That is the link. So that will form the closed circuit. Loop 1. Current flowing through the loop 1 is I1 in clockwise direction. This is loop 2. Current flowing through loop 2 is I2. That also clockwise direction. Loop 1 contains the branch 1, 2, 5. Loop 2 contains the branch 3, 4, 5. From this we can go for the tie set schedule. So this vertically we have the loop number. Loop 1, loop 2, 1 and 2. Horizontally we have branch numbers. There are 5 branches are there. 1, 2, 3, 4, 5. The loop currents are described by the small letter I1, I2. The branch currents are described by capital letter I1, I2, I3, I4, I5. Now we can see the relation. The plus 1 indicates both the directions are same. Minus 1 indicates both the directions are opposite. That is the loop current and branch current direction. 0 means there is no current. Now see this current I1 is flowing in clockwise direction. See the current direction of branch 2 and loop 1 both are same. So this is also flowing this side. So branch 2 is plus 1. Branch 5, that also same. Going down, both are going down. So plus 1. In loop 1, so it is flowing like this, clockwise direction. So that also same, plus 1. 3 and 4, the loop current I1 is not flowing through 3 and 4. So 0, 3 and 4, 0. 2, 1, 2, 5, all are same direction. So it is indicated plus 1. Now we'll see the loop 2. See the direction, branch 3 and I2 both are same, plus 1. Here also same. So plus 1. See this side, here this I2 is going upward, but branch current 5 is going downward. So minus 1. 1 and 2 no connection. Branch 1 and 2 not covered with the loop 2. So 0. So this is called a tie set schedule. Tie set diagram and tie set schedule. Loop current and branch currents are related. Both the directions are same in plus 1. Opposite means minus 1. Not flowing means 0. From this we can easily write the voltage equation and current equation. We can see later, but I will explain how to write the voltage equation. So this consider the first row. So 1 into V1 plus 1 into V2 plus 0 into V3 plus 0 into V4 plus 1 into V5. Like that we can write the equation. Similarly in the second row, 0 into V1 plus 0 into V2 plus 1 into V3 plus 1 into V4 plus minus 1 into V5. We can write the voltage equation. Similarly, I will write the current, branch current I1. See this I1. I1 in terms of loop current. So this is only plus 1 is available. One loop 1 plus 1. Loop 2 0. So I1 equal to capital I1 equal to small I1. Because here two currents are there. One current is 0. So only 1. So capital I1 equal to small I1. Similarly I2. Only here plus 1 is there. I1 is plus 1. I2 is 0. So capital I2 also small I1. For I3. I1 is 0, I2 is 1. So capital I3 equal to small I2. Similarly I4 also. I1 is 0, I2 is plus 1. So capital I4 equal to I2. Right? So I1 equal to capital I1 equal to small I1, I2 equal to small I1, I3 is small I2, I4 also small I2. For I5 both the values are available, plus 1, minus 1. So we need to subtract I1 minus I2, positive minus negative. I1 minus I2, capital I5 equal to I1 minus I2. So we can write the voltage equation as well as the current equation, branch current in terms of loop current from the tabular column. Now we will see the further. I1 and I2 are the link current. The branch currents are capital I1 to I5. V1 to V5 the voltages of the branches 1, 2, 3, 4, 5 respectively. Right. Now we see the voltage equation. What we discussed, voltage and current, we will see the relation. So what we discussed here, for the first row we can write 1 into V1 plus 1 into V2 plus 0 into V3 plus 0 into V4 plus 1 into V5. So these values are from the tabular column, tie set schedule. So these two values are 0, only we have V1 plus V2 plus V5 equal to 0. We will take the equation number 1. Similarly second row, 0 into V1 plus 0 into V2 plus 1 into V3 plus 1 into V4 plus minus 1 into V5. So first two values are 0 over V3 plus V4 minus V5 equal to 0. We'll take this equation number 2. So from the tabular column tie set schedule, we got the voltage equation, two equations. For the two rows, we got the two equations. Now we'll go to the current equation. What is the current equation from the tie set schedule? So this is the current equation, what we discussed already. Capital I1 equal to small I1, I2 equal to small I1, I3 equal to small I2, I4 equal to small I2. This is not I4, I2. I5 equal to I1 minus I2. So the equation 3, 4, 5, 6 are. Now branch voltages, there are 5 branches are there. V1 equal to minus 20, V2 equal to 10 I2, V3 equal to 10 I3, V4 equal to minus 40, V5 equal to 10 I5. What is this value? This 20 is the voltage source already available. This minus 40 also voltage source. This is V equal to I into R. R value is 10 ohm. I value is I2. Now we will refer the diagram so that it is easy to understand. So this is the branch 1. Branch 1 is minus 20 voltage. Branch 4 is minus 40 voltage. Branch 2 V2 is nothing but 10 ohm. So 10 into I1. This 3 is nothing but this 10 ohm. 10 into I2. This 5 is nothing but 20 ohm. But here both the currents are flowing, I1 and I2. So I1 minus I2. 20 into I1 minus I2. So that is written in that equation. Now in this voltage equation, we can substitute the value of I2, I3 and I4 from these equations. So that we can able to find the branch voltage and current. So that the V1 already available minus 20, V4 is minus 40. Only we need to find V2, V3 and V5. V2 equal to 10 into I2. But I2 is nothing but small I1. So 10 I1. V3 is 10 I3. I3 is nothing but I2. 10 I2. V5 equal to 20 I5. I5 is nothing but I1 minus I2. 20 I1 minus I2. Right. So now we got this V2, V3, V5. V1 and V4 already available. So we can substitute this equation in the first and second equation. That is the voltage equation. From row 1 and 2 we got two equations. In that we can substitute these values. Now consider the equation 1. V1 plus V2 plus V5 equal to 0. Now we'll substitute the value of V1, V2 and V5. V1 is minus 20. V2 is 10I. V5 is 20 of I1 minus I2. Now we'll multiply this so that 20 I1 minus 20 I2. So minus 20, 10I plus 20I become 30I. Minus 20 I2 equal to 0. Bring this minus 20 that side, so it become plus 20. So divide by 10 so that 30 become 3I, 20 become 2, 20 become 2. So 3I1 minus 2I2 equal to 2. I will take this equation number 13. Now we'll go to the second equation. V3 plus V4 minus V5 equal to 0. Now substitute the value. V3 is 10I2 plus V4 is minus 40. V5 is 20 of I1 minus I2. We'll multiply inside. So minus 20I plus 20I2. This minus and minus become plus. So 10I2 here. 20I2 is there, so it becomes 30I2. Then minus 20I1 minus 40. Bring this minus 40 that side, it become 40. Here also divide by 10, so it become minus 2I1 plus 3I2 equal to 4. This is equation number 14. So we need to find the value of I1 and I2. Now we got two equations, 13 and 14. For finding two variable, we have two equations. By solving these two equations, we can easily find the value of I1 and I2. See here 3 I1 is available, here minus 2 is I1 is available. So we'll multiply the equation 30 with 2, equation 14 with 3. So that we'll get 3 into 2, 6. We can easily cancel the term I1. Now we'll go for the simplification. So equation 13 is multiplied with 2, equation 14 is multiplied with 3 in order to bring this I1 as 6. So here plus 6I1 minus 6I1. So simply we can add the value, so that while adding it automatically got cancelled. So 9I2 minus 4I2. So 5I2. 12 plus 4, 16. So I2 equal to 16 by 5, that is nothing but 3.2. So I2 equal to 3.2 amperes. Now we got the value of I2. Now we can substitute this I2 value in equation 13, so that we are able to find the value of I1. So we will consider equation 13, 3I1 minus 2I2 equal to 2. Substitute the value of I2 equal to 3.2 ampere. So 3I1 minus 2 into 3.2 is 6.4 equal to 2. Bring this 6.4 that side, so it becomes 6.4. 2 plus 6.4, 8.4. So I1 equal to 8.4 divided by 3, that is 2.8. I1 value is 2.8 amperes. So now we got the value of I1 and I2. So the loop currents are calculated. Now we will go to the branch voltages. By using this we can easily calculate the branch voltages. So V1 equal to minus 20 voltage already available. This is a voltage source. V2 equal to 10 I1. I1 value is 2.8. So 28 voltage. V3 equal to 10 I2. I2 value is 3.2. So 32 voltage. 10 into 3.2, 32 voltage. V4 is minus 40 voltage. This is a voltage source already available. V5 equal to 20 I1 minus I2. That is 20 of 2.8 minus 3.2. So 20 into minus 0.4. 2.8 minus 3.2 is minus 0.4. So that is 20 into minus 0.4 is minus 8 voltage. So now we calculated the branch voltage also. So in this problem we discuss the tie-set schedule. Given network, first we draw the oriented graph, then tree with the link is called a tie-set. From that we receive the tie-set schedule. Using the tie-set schedule we framed the voltage equation and current equation. By solving these equations we are able to identify the value of loop current I1 and I2. From that we calculated the branch voltage V1 to V5. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the details about cut-set schedule tree branch voltages. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. One of the topic in network topology, cut-set schedule tree branch voltage. To find the branch voltages and current in a network, there is another method is available. There are two methods, tie-set schedule, cut-set schedule. This is coming under cut-set schedule. We can treat the tree branch voltages as independent variable. Then all the voltages can be expressed in terms of the tree branch voltages. So we are going to express the voltages in terms of the tree branch voltages. As tree branch connect all the nodes in the network, we can trace the path from one node to another node by traveling around the tree branch only. So the tree branch means it will connect all the nodes, so that we can trace the path from one node to another node by the tree branches. So it is possible to express the potential difference between any two nodes. It is commonly known as node pair voltage. So we can possible to express all the potential difference between the two nodes. Now we'll consider the network. We'll see the diagram. So this is the oriented graph. Oriented graph means the graph means the network is replaced by the line. Here this line indicates the network elements. Network elements are replaced by the line. It's called a graph. If the direction also available means it's a oriented graph. We are able to see what is the direction, how it is traveling, right? So the network element replaced by the line is graph. The direction also available means it is a oriented graph. So here there are 4 nodes are available, A, B, C, D. Node means connection of junction point of more than one elements. Here this element 1, 8, 4 are connected. Similarly here 1, 5, 2 are connected. So the node is the junction point, connection of more than one element. There are 8 branches available. Branch is nothing but connection between the nodes. The element connected between the node is called a branch. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 branches are available. So we already know that we are going to go for deal the topic cut set schedule using the tree. So from this oriented graph we can draw the tree. There are n number of trees available from the oriented graph. This is one of the tree we consider. The tree is the subgraph, contain the less number of branches. Here only 4 branches we consider. That is 5, 6, 7, 8. These inner branches we consider. These outline branches are not drawn. 1, 2, 3, 4 are not available. So this tree is the subgraph, contain less number of branches. Here branch 5, 6, 7, 8 is available. 1, 2, 3, 4 is not covered. This is one of the tree. Like that we can draw many trees. So here A, B, C, D, 4 nodes, branches 5, 6, 7, 8. The potential across this branch B, node B and reference is E1, E2, E3, E4, because we are going to find the tree branch voltage. So our aim is to find E1, E2, E3, E4. So that is more. E1 is nothing but the branch voltage between node B and reference node. E2 is between C and reference node. E3 is D and reference node. E4 is A and reference node. Here some of the branches are not covered, so that will come under the cut set. Here this branch is not connected. So here we have one cut set here and another cut set will be here. So here also not connected. So there are possible 4 cut sets are possible here. So tree is the connection of branches, less number of branches. The branches were not connected, not covered. That will act as a cut set schedule. Here 1, 2, 3, 4 branches are not connected. Outlines are not connected. So that 4 corners will act as a cut set schedule. So that is the important concept. We'll see the cut set schedule later, right? So this is the oriented graph. From that n number of trees are there. We consider this tree. By analyzing the tree, we are able to see that there are 4 cut set schedules are available. Now we'll see what are the diagram for the cut set schedule. Assume that V1 to V8 are the voltages at the branches 1, 2 up to 8 respectively. So V1, V2, V3 up to V8 is the branch voltage. There are 8 branches available. Branches 5, 6, 7, 8 form the tree. We already know that the inner branches 5, 6, 7 form the tree. So V5, V6, V7, V8 are the voltages of these branches respectively. Right? This tree contain the branches 5, 6, 7, 8. The corresponding voltage V5, V6, V7, V8. Now we'll go for the further details. The tree branch voltages form a set of independent variables. To distinguish them from a dependent variable, we designate the independent variables are E1, E2, E3 and E4. Right? So the V1, V2 up to V8 is the branch voltage. The tree branch voltages indicated by E1. E1, E2, E3, E4. E1 is equal to V5, E2 equal to V6, E3 equal to V7, E4 equal to V8. So we can identify the tree branch voltage. The other branch voltage is also known as a link voltage. I already told inside the branches are available 5, 6, 7, 8. Voltage is V5, V6, V7, V8. The corresponding tree branch voltage E1, E2, E3, E4. But V1, V2, V3 is not covered. That is the other branch link. That coming under link voltage. These are expressed in terms of tree branch voltage. So V1 equal to E1 minus E2 because V1 is connected between E1 and E4. V2 is connected between E2 and E1. So E2 minus E1. V3 equal to E3 minus E2. V4 equal to E4 minus E3. Now we'll see how we are getting V1 equal to E1 minus E4. So refer this diagram. So this is the V1. The between node A and B is the V1, right? So here V1, this is nothing but a potential difference between E1 and E4. So E1 minus E4. Similarly V2 is connected between B and C, E1 minus E2. Then V3 connected between C and D, E2 minus E3. V4 connected between C and D, E3 minus E4. Right? So inside the voltages as clearly mentioned, outside the tree branch voltage is nothing but difference between these two voltages. So based on that, these four voltages are written, right? V1, V2, V3 and V4. So that will act as a link voltage. In case of a complicated network, this method is very tedious and confusing. Hence we write the schedule called a cut-set schedule. If it is complicated, it becomes tedious. So we can go for a cut-set schedule. I will refer the diagram. So this is the cut-set schedule. So this is a cut-set schedule. It's a diagram. Cut-set schedule diagram. So there are inner branch 5, 6, 7, 8 is coming under the tree. Outside not covered. Now it is outside line also drawn. That acts as a cut-set. C1, C2, C3, C4. There are 4 cut sets are available. From the oriented graph, tree is drawn. In the tree, the branches not covered act as a cut set. Branch 1, 2, 3, 4 are not covered in the tree. So branch 1 act as a 1 cut set, C1. Branch 2 act as a 1 cut set, C2. Branch 3 act as a 1 cut set, C3. Branch 4 act as a 1 cut set, C4. Right? Wherever the branch not covered in the tree, that will act as a cut set. Here 4 branches are not covered, so 4 cut sets are available. Now we'll see the tabular column. Tree branch voltage. Tree branch voltage means E1, E2, E3, E4. Already know that E1, E2, E3, E4. Tree branch voltage. The branch voltage is V1, V2, V3 up to V8. That is the voltage between the nodes. So the branch voltage. Tree branch voltage means is a E1, E2. We already have the 2 different notation. Now we can rate these two, tree branch voltage and the branch number. First we will consider the node 1, tree branch voltage V1. So that is connected between A and B. Right? A and B. Right? A and B is connected. Now consider this E1, tree branch voltage E1. So at this point, we'll analyze all the things. Here 1, 5, 2. These three branches are connected. Other branches not connected. 3, 4, 6, 7, 8 not connected. Only 1, 2, 5 connected. See the direction of the branch and the cut set. Both are opposite. Right? Branch 1 and C1 both are opposite, mean plus 1. In 2, branch 2 both are same direction, mean minus 1. 3, 4 not connected, 5 is connected, 5 also opposite direction. Branch voltage and cut set schedule direction both are opposite, so plus 1. Right? If both the directions are opposite to each other, both are opposite mean plus 1. Both are same. Here also going upward, this also going upward means minus 1. The branches not connected are 0. Then we'll go to the E2. The branch voltage, tree branch voltage E2. So E2 is available here. Right? E2. Here 2, 3, 6 are connected. 2, 3, 6. Other branches are 0. 1, 4, 5, 7, 8 are 0. First we'll see the 2. See the direction both are opposite, so plus 1. Then C3, both are same direction, so minus 1. 6, both are opposite, so plus 1. Then we'll go to the C3. C3, what are the branches connected? 4, 7 and 3. Other branches are 0. First we'll see the 3. 3 both are opposite direction, plus 1. 4, same direction, minus 1. 7, also opposite direction, both are opposite, plus 1. Then we'll go to the C4, the voltage E4. Here, what are the branches connected? 1, 4, 8. Right? 1, 4, 8 are connected, other are 0. First we'll see the 1. See, both are same direction, going this side. So minus 1. 4, both are opposite direction, plus 1. 8 also opposite direction, plus 1. So accordingly, this tie set schedule is calculated. See the voltage V1, V2, V3, V4, V8. Right? So the V1, we consider V1, it is connected between the node B and A. That is E1 and E4. So E1 plus 1, E4 minus 1. That also, like that also we can see that. So I will explain again one. E1 cut set schedule C1. 1, 2, 5 are connected. 1, 2, 5 are connected. 3, 4, 6, 7, 8 not connected. So 1 is connected. Both are opposite direction, plus 1. 2 is going same direction, minus 1. 5 is opposite direction, plus 1. Like that we can go for the tie set schedule. Now we'll go for the further analysis. So from the tabular column, how we can go for the further analysis. E1, E2, E3 are the cut sets. The direction which are given shown. Number of cut set equal to number of node minus 1. Refer the graph with cut set. The 3 branch voltage numbers 1, 2, 3, 4 are entered in the first column. They corresponding to the 4 branches 5, 6, 7, 8 respectively. What we did is the description is given. To fill up the first row, consider the cut set schedule C1. It cut the branches 1, 2 and 5. So the first row, all entries will be 0 excepted the branch 1 to 5. Right? 1 to 5 only we are filled, other things are 0. This 1 to 5 based on the direction. Opposite direction means plus, same direction means minus 1. Similarly, we can go for the other rows. The orientation of cut set is opposite to the direction of branch means 1, 1 and 5. So the orientation of cut set schedule is opposite direction of the branch 1 and 5. Hence its value is plus 1 and minus 1 in the first row. Below the branch 1 and 5. The direction of cut set C1 is same as that of 2. So it enters as minus 1 in the below branch 2. Right? The same direction means minus 1. Opposite direction means plus 1. Similarly, using cut set C2, the second row is filled up. Cut set C3 and C4 also filled up the third and fourth row respectively. By using the same rule we can fill. So after writing this, what we can do? After writing the schedule, we can get the equation of 4 branch voltages in terms of the 3 branch voltages. Thus column 1 gives the equation for V1 in terms of 3 branch voltage. In the similar manner, V2 to V8 also obtained in terms of 3 branch voltages. By seeing the column of the cut set, we can get V1 equal to E1 minus E4. Right? How will get V1 equal to E1 minus E4? So this is the cut set schedule available. Vertically what we have? 3 branch voltage. Horizontally we have branch voltage. See the V1. Here plus 1 minus 1. E1 is plus, E4 is minus. So E1 minus E4. E2, E3 is 0. So based on that we can write V2. E1 is minus 1, E2 is plus 1. So E2 minus E1. V3. E3 is plus 1, E2 is minus 1. So E3 minus E2. Like that we can write. Welcome viewers, in this video we will see the solved problem based on the cut set schedule. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Cut set schedule solved problem coming under network topology. Now we'll see the problem statement. Find the cut set matrix and the branch voltages current for the network shown below. So this is the network given. Network is nothing but connection of the elements, network elements. Here 3 resistors are available and one voltage source is available. It is connected together. It's called a network. The question is we need to find the branch voltage and branch current. Here there are 3 nodes are available. Node is nothing but junction point of the elements. Node A, B and C. At node A, voltage source, this 2 ohm, another 2 ohm connected. At node C, this 1 ohm and these 2 ohms are connected. At node B, this voltage source and 1 ohm is connected. Node is nothing but connection of junction point, connection of the network element, junction point at which network elements are connected. From the network we can draw the oriented graph. The graph is nothing but the network elements are replaced by the straight line, replaced by the line. It's called a graph. The direction also available mean oriented graph. Here this voltage source is replaced, is named as branch 1. These 3 resistors also replaced by the line and named as 2, 3, 4. This 1 ohm is 2 and these 2 ohms are named as 3 and 4. These directions are given according to our own direction. Directions are not given in the problem. It is randomly the directions are given. So the network, from that we drawn the oriented graph. Oriented graph means network elements are replaced by the line and the direction is available. So from this the number of node equal to n equal to 3, ABC. 3 nodes are available. So the number of cut set is n minus 1, 3 minus 1, 2. So for this given network there will be 2 cut sets are available. Now we will see how to draw the cut set. First we need to draw the tree. Tree is nothing but subgraph of the oriented graph, subgraph having less number of branches. There are n number of trees we can draw. This is one of the tree covering the branch 2 and 4. Node A, B, C, there is a tree. This one type of tree having the branch 2 and 4. 1 and 3 is not covered. Branch 1 and 3 is not covered. So that 1 and 3 will form the cut set, 2 cut set. At node C all are connected. At node B not connected, 1 is not connected. At node A 3 is not connected. So the node B will form one cut set, node A will form another cut set. So there are 2 cut sets are available. There it is given at node A and node B. Now we'll see the cut set. So the tree in that the branches not covered will form the cut set. This branch 1 is not covered, 3 also not covered. So 3 not covered at node A form one cut set. This is the cut set. At node B branch 1 not covered, that form another cut set, C1 and C2. Right? So the graph redrawn with the cut set C1 and C2. So the network from that oriented graph, from oriented graph we have drawn the tree. From the tree where the branch is not covered, we can draw the cut set matrix, cut set diagram. From this diagram we can go for the cut set schedule. We can frame the tabular column, cut set schedule. So this 1, 2, 3, 4 are the branches. V1, V2, V3, V4 are the branch voltages. E1 and E2 are the tree branch voltages. That is this 1 and 3 is the tree branch voltages. E1 and E2 is nothing but tree branch. This is a branch. At C1 the tree branch voltage is E1. At C2 the tree branch voltage is E2. So this tabular column we have the branch voltage V1, V2, V3, V4. Tree branch voltage is E1 and E2. The notation is different. Tree branch means this is tree branch 2 and 4 is a tree branch. Right. Now we can frame the tabular column. Right. Now we'll see the cut set schedule C1. First we'll see the cut set schedule C1. Here 1 and 2 is connected. See the direction, the branch direction of 1 and cut schedule both are opposite, means +1. See the branch direction 2 and cut set both are same direction going this side is -1. 3 and 4 is not connected with the C1, so 0. So at branch 1 cut set C1 direction both are opposite +1, both are same -1, not connected 0. Then cut set schedule C2, 1, 3, 4 are connected, 2 is not connected, so 2 is 0. 1 is connected, see the direction, same direction, -1. 3 and 4 opposite direction, so +1. So accordingly we can frame this cut set schedule. So vertically we have 3 branch voltage E1 and E2 based on the 2 cut set. Vertically we have, horizontally we have branch voltage V1, V2, V3, V4. There are 4 branches. Both are related. At C1, 1 and 2 connected. 3 and 4, 0. 1 is opposite, so +1. 2 is same, -1. At C2, 1, 3, 4 are connected. 2 is not connected, 0. 1 same direction, -1. 3 and 4 opposite direction, +1. So this is the cut set matrix. Based on this 1, -1, 0, 0, -1, 0, 1, 1. So from this cut set matrix we can go for the voltage equation as well as current equation. How will you find the current equation? See in this, I1 minus I2 equal to 0. I3, I4 are 0, already 0. The second row, minus I1 plus I2 plus I3 equal to 0. By using the Kirchhoff's current law, we can write the equation. I1 minus I2 equal to 0. Minus I1 plus I3 plus I4 equal to 0. We can write the two equations. Similarly, we can write the voltage equation. How will you write the voltage equation? V1. Here +1, -1. E1 is +1, E2 is -1. So we can write E1 minus E2. V1 equal to E1 minus E2. V2, only E1 is available, -1. So V2 equal to minus E1. E2 is 0. V3, only E2 is available, +1. So V3 equal to E2. V4, only E2 is available, 1. This is 0. So V4 equal to E2. Right? So V1 is E1 minus E2. V2 is minus E1. E2 is 0. V3 is plus E2. E1 is 0. V4 is plus E1. So we can write the voltage equation. So from the cut set matrix, we can able to write 4 voltage equations and 2 current equation. Now we'll see this in detail. So what we discussed is available as a equation. For the row, we can apply KCL. Let I1, I2, I3, I4 be the branch current of the branches 1, 2, 3 and 4 respectively. So by applying KCL to the row 1, we already discussed I1 minus I2 equal to 0. Take this equation number 1. By applying KCL to the row 2, minus I1 plus I3 plus I4 equal to 0. That we already discussed is equation number 2. So we are able to frame the 2 current equation by using the KCL. Similarly, let the branch voltages are V1, V2, V3 and V4 for the branches 1, 2, 3 and 4 respectively. E1, E2 is the tree branch voltage. V1, V2, V4 is branch voltage. So what we discussed from the column, we can able to write V1 equal to E1 minus E2. V2 equal to minus E1. V3 is E2. V4 is E2. So what we discussed in the matrix, we are able to write the 4 voltage equation. It's numbered as equation 3, 4, 5, 6. This current equation 1 and 2. Other equation 3, 4, 5, 6. So by using this 6 equation, we are able to find the branch voltage and branch current. Now we can redraw the network indicating the current direction. So this 30 voltage source available and 3 resistor, 1 ohm, 2 ohm and another 2 ohm. The node are A, B and C. Let the current from the voltage source is I1. So the I1 is flowing through 1 ohm resistor. I1 is current is flowing from the voltage source. The current flowing through 1 ohm is I2. Then I2 is splitted I3 and I4. So current flowing through this 2 ohm resistor is I3. This 2 ohm resistor is I4. So there are 4 currents. I1 current flowing from 30 voltage source, I2 current flowing through 1 ohm resistor, I3 current flowing through this 2 ohm resistor, I4 current flowing through this 2 ohm resistor. From that we can write the voltage equation. So V1 equal to minus 30 because of negative polarity, minus 30. Current is flowing from the flowing in the reverse direction. So this minus 30. V2 is nothing but V2, V equal to I into R. I is nothing but I2. R is 1 ohm. 1 ohm into I2. Then V3 equal to V equal to I into R. I is I3. R value is 2 ohm. 2 into I3. Similarly V4, 2 into I4. So V1 equal to minus 30. V2 equal to I2. V3 equal to 2I3. V4 equal to 2I4. Equation number 7, 8, 9, 10. Already we have 6 equation available. First 2 equation current. Remaining 4 equation voltage. So here we have another 4 more equations are available for the voltage. Now we can compare equation 3, 4, 5, 6 voltage with this 7, 8, 9, 10. Both are same. By comparing that we can able to find the voltage value. So 3, 4, 5, 6, 7, 4 equation, one set of voltage equations available. 7, 8, 9, 10, another 4 set of voltage equation available. So first we will take equation 3. That's nothing but V1 equal to E1 minus E2. But equation 7 we have V1 equal to minus 30. Value is available. So we can replace V1 equal to minus 30. So minus 30 equal to E1 minus E2. Brought that minus 30 that side, so it become plus 30. That is E1 minus E2 plus 30 equal to 0. Right? Equation 3, V1 equal to E1 minus E2. At equation 7 we have the V1 value is available, minus 30, that is substituted, and we framed the one more equation 11. Then equation 4 is V2 equal to minus E1. But from equation 8 V2 equal to I2. So both are same. So I2 equal to minus E1. Equation number 12. Equation 5 V3 equal to E2. But from equation 9 V3 equal to 2I3. So both are same. This right side is same. So the left side also same. 2I3 equal to E2. Equation number 13. Equation 6 is V4 equal to E2. But from the equation 10 V4 equal to 2I4. So both are same. 2I4 equal to E2. This is equation number 14. Now we have the equation 11, 12, 13 and 14 available. But from equation 1, I1 minus I2 equal to 0. So that brought this I2 that side, so it become plus I2. So I1 equal to I2. We got one more relation, I1 equal to I2. Equation number 15. Now we'll go for the further simplification. Now we'll take the equation 11. What we framed equation 11 is E1 minus E2 equal to minus 30. From equation 2, minus I1 plus I3 plus I4 equal to 0. Now all these values are available. From equation 12, 13, 14, these values are available. I1 equal to I2. Just now we discussed I1 equal to I2. So I1 is replaced by I2. Both are negative. I3 is E2 by 2. I4 is E2 by 2. So that is from the equation 12, 13, 14. So I2 can also replace as minus E1 plus E2 by 2 plus E2 by 2 equal to 0. So negative it become positive E1. So E2 by 2, E2 by 2, 1 by 2 plus 1 by 2 is 1. So it become E2. So E1 plus E2 equal to 0. We have 17, equation number 17. But equation 16 what we have, E1 minus E2 equal to minus 30. This equation 16. But in equation 17 what we have, E1 plus E2 equal to 0. So we can add both the equation, because by adding this E2 got cancelled. So E1 plus E1, 2E1 equal to this got cancelled, minus 30. So E1 equal to minus 30 divided by 2. So the E1 equal to minus 15. Now we got the one value E1. There is nothing but branch tree voltage. E1, E2 is the branch tree voltage. Now from equation 17, E1 plus E2 equal to 0. E1 we calculated, E1 is minus 15 plus E2 equal to 0. Brought this minus 15 that side, become plus 15. So E2 equal to 15 voltage. So E1 equal to minus 15 voltage, E2 equal to plus 15 voltage. Now we calculated the voltage. Now we'll go for the current value. I1, I2, I3 and I4. Before find the branch voltage, we'll find the branch current, we'll find the branch voltages. That is V1, V2, V3 and V4. E1, E2 already calculated. From that we can easily calculate V1, V2, V3 and V4. V1 equal to, from equation 3, V1 equal to E1 minus E2. So we calculated E1 is minus 15 minus E2 is plus 15. So minus 15 minus 15 minus 30 voltage. V1 equal to minus 30 voltage. From equation 4, V2 equal to minus E1. Minus of E1 is minus 15. Minus of minus 15 become plus 15. V2 equal to 15 voltage. From equation 5, V3 equal to E2. E2 value is 15 voltage. So that V3 equal to 15 voltage. From equation 6, V4 equal to E2. E2 is 15 voltage. So that V4 equal to 15 voltage. Now we got the branch voltage. V1 equal to minus 30 voltage. V2 equal to 15 voltage. V3 equal to 15 voltage. V4 equal to 15 voltage. Now we got the E1, E2 value as well as V1, V2, V3, V4 value. Now we'll go for the branch current. Now we'll find the branch current one by one. So from equation 1, I1 minus I2 equal to 0. So that I1 equal to I2. Brought the I2 that side, so it become plus. I1 equal to I2. But from equation 12, I2 equal to minus E1. From equation 12 it is available. So I2 is replaced by minus E1. So minus of E1 is already minus 15. So minus of minus 15 become 15 amperes. So the branch current I1 is 15 amperes. From equation 12, I2 equal to minus E1. Minus of E1 is already minus 15. So minus of minus 15, 15 amperes. E1 equal to minus 15 voltage. So I1 equal to 15 amperes, I2 also 15 amperes. Now we'll find I3 and I4. From equation 13, 2I3 equal to E2. So I3 equal to E2 by 2. We know that E2 is 15 voltage. So 15 by 2, 7.5 amperes. I3 value is 7.5 amperes. From equation 14, 2I4 equal to E2. So that I4 equal to E2 by 2. That is E2 is 15. 15 by 2, 7.5 amperes. So E2 also 7.5 amperes. So now we calculated I1, I2, I3 and I4. I1 is 15 ampere, I2 is 15 ampere, I3 and I4 is 7.5 ampere respectively. So now we calculated branch voltage as well as the branch current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.